Welcome to this explainer. Look, today we're going to do something a little bit different. We are going to treat your Cambridge AS and A-level mathematics exam literally like a blockbuster film, and we are going to build your answers scene by scene. I'm your host. Think of me as your executive producer or your head strategist, and today we are stepping right into the director's chair. We're going to cut the filler, we're going to keep the action, and we are focusing entirely on mastering syllabus code 9709 integration. Specifically, we're zeroing in on the absolute undeniable star of the show, the notorious constant of integration. Seriously, think of your exam paper as a blank script. Every single line of working you write down is a scene, and it needs to advance the plot toward that final, perfect, undeniable solution. Now, whether you built your foundations in IGCSE 580 or O-Level 4024 and 4040, or maybe you worked your way through 0606 and 4037 additional math, and even if you're eyeing 9231 further math down the road, this right here, 9709, is the proving ground. If you've ever felt like you totally understand the math in the classroom, but then you sit down in that dead silent exam hall and just completely freeze up, or maybe you're consistently dropping marks on practice papers and you just can't figure out why, well, you are exactly in the right place. Grab your notes because we are going to deconstruct the precise, no-nonsense strategies that top-tier candidates use to secure absolutely full marks. Okay, let's just dive right into this truly shocking fact on the screen: 15%. Let that sink in for a second. Integration, and specifically the correct application of the constant of integration, accounts for roughly 15% of the total marks in Paper 2. We are not talking about some obscure and niche topic that might show up once every 5 years to trick you. No way. We are talking about a massive, foundational pillar of the entire Cambridge mathematics syllabus. Forgetting that little plus C or failing to calculate it correctly using your boundary conditions, that isn't just a minor slip-up. It's a critical red alert error that can literally single-handedly drop you an entire grade boundary. I've seen it happen. It affects your coordinate geometry when you're desperately trying to find the equation of a curve from a gradient function. It ruins your kinematics answers when you're trying to find displacement from a velocity equation. 15% of your total success is riding on this single vital concept. It's make or break, guys. So, here is our master script for today's explainer. 1. The 15% challenge. 2. Core concepts and definitions. 3. The 4-step methodology. 4. Top examiner warnings. And finally, number 5, the mastery blueprint. Let's get into it. Section 1, the 15% challenge. And we're going to look at this through the lens of two very different students, Alex and Sam. Let's set the scene. Imagine a real Cambridge mathematics past paper question bridging those foundational concepts straight up to the rigorous AS level 9709 standard. The question asks you to find the exact equation of a curve given its derivative and a point it passes through. Pretty standard, right? Well, look at the split screen here to see how our two characters handle this. Over on the left, we've got Alex. Alex has what I call the flawed answer by fact overload. Alex looks at the problem and just starts integrating everything in sight. No plan, just vibes. He writes down the integration rules perfectly. He gets the powers right, he divides by the new power, but then he just stops. He leaves this raw, untamed mathematical expression sitting on the page. There's zero analysis. It's like filming a beautifully lit, expensive scene that has absolutely nothing to do with the movie's actual plot. The examiner's just sitting there asking, okay, but what does this mean? Now, pan over to the right. Here is Sam. Sam has the opposite problem. Sam is rushing. Sam thinks he's in a race. He shows a complete lack of respect for the examiner's command words. Sam integrates, slaps a sloppy plus C at the end of the line, and just completely ignores the command phrase, find the exact equation. He never substitutes the coordinates in to find out what C actually is. And the examiner's red pen is just circling and circling that missing constant calculation. Listen to me on this. Neither of these students secured the marks. Why? Because they aren't treating their working as a connected, logical, step-by-step argument. They're just throwing math at a wall and hoping it sticks. Moving on to Section 2, Core Concepts and Definitions. This is where we build your theoretical architecture.
You see, top-performing students, the ones walking away with the A stars, they do not view math in isolated silos. They build a solid theoretical architecture that connects all these different topics together into one big picture. When you are deep into syllabus 9709, you absolutely cannot treat algebra, calculus, and geometry like they are separate islands. They aren't. The constant of integration, it is the ultimate bridge. It bridges the abstract, purely theoretical operation of calculus with the tangible physical reality of a geometric curve or particle in actual motion. Think about it. Without that constant, what do you have? You just have an infinite family of parallel curves floating in space. With it, you have the exact curve, the one and only curve the examiner cares about. Now, what's really fascinating about this slide is that principal examiner reports consistently highlight that candidates who reference cross-topic connections achieve significantly higher marks. It's true. For example, if velocity is the rate of change of displacement, well, then obviously integrating velocity gives you displacement. But wait, the particle had to start somewhere, right? It didn't just pop into existence. That starting position, that anchor to reality, that is your constant of integration. When you shift your mindset to define the constant as the vital, non-negotiable piece of data that anchors your equation to a specific physical context, you actually stop forgetting to write it down. It goes from being a chore to being a logical necessity.
Before we get into the exact methodology to fix all of this, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Go ahead, click that subscribe button, and hit the bell icon right now so you don't miss any of our deep dive strategy sessions. Building these core concepts is how you stay ahead of the curve. All right, Section 3, the 4-step technical methodology. This right here is your procedural framework. Listen, knowing the underlying math. That is only Act 1 of our movie. Act 2 is getting it onto the paper so clearly that the examiner is practically forced to give you the marks. They shouldn't have to guess what you're doing. So we're introducing an adapted Peel framework, specifically for math. Point, evidence, explanation, link. Let's tie this into the 4 actionable step-by-step points you see on the screen. Step 1, deconstruct and extract data. This is your point. You go in with a highlighter, you target the command word, and you rip out the boundary conditions from the text. Step 2, select analytical framework. This is your explanation setup. You pause, you step back, and you decide your integration technique. Do you need to expand some brackets first? Are you dealing with a tricky negative exponent? Figure it out before you write. Step 3, execute with clear notation. This provides your evidence. This is where you substitute specific values. And a massive rule here. Do not, under any circumstances, drop your integral signs until you have actually physically performed the integration. And the exact millisecond those integral signs vanish, boom, the plus C must appear. It's a direct swap. Step 4, present correct terminology. This is your link. If the question explicitly asked for a function f of x, your final line must explicitly link back to that. You state, f of x equals your integrated expression complete with the correctly calculated constant. That is a mic drop answer. Let's zoom in on why this structure is basically an exam superpower. This builds into the most critical strategy of all. Showing you're working is your ultimate, undeniable insurance policy. Look at this quote. This is literally straight from a principal examiner alert. Even if your final answer is wrong, method marks can save you. Okay, let's play out a scenario. Let's say you execute your integration perfectly, it's beautiful, you add your plus c, you perfectly substitute your coordinates, let's say x equals 2 and y equals 5. But then, the clock is ticking, you're sweating, it's the heat of the exam, you make a silly, ridiculous arithmetic error. 2 squared becomes 8 in your panicked brain instead of 4. We've all been there. So, your final value for c ends up being wrong. Now, if you had just done the math in your head and only wrote down the final wrong answer, you get 0 marks, absolute 0. But because you structured your answer like a director, physically writing down the exact substitution step and explicitly showing the examiner how you intended to find C, you secure the method mark. You get paid for your strategy, even if your calculator thumb slipped. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 whole grade boundaries just by fixing these structural leaks. Join them right now by subscribing to Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Locking in this methodology is the secret sauce. Okay, Section 4. This is our interactive workshop on top examiner warnings. We are going straight inside the examiner's mind. We are heading straight into the editing room right now to look directly at the top 3 agonizing red pen mistakes pulled verbatim from Cambridge principal examiner reports. Year after year, the exact same critiques just keep appearing regarding integration. Examiners constantly warn that students bleed easy marks because of these 3 things. Number 1, their answers are just too vague. They do the integration, but they completely fail to explicitly state what the resulting function actually represents. Like, are you finding a generic y, or are you finding a physical displacement s? State it. Don't make the examiner guess. Number 2, poor format and presentation conventions. Oh man, we see this all the time. This is when students use the integral sign while performing the integration, creating this hideous, messy hybrid of differentiated and integrated terms on the same line. It makes the examiner wince. And number 3, the absolute killer. Answers not specific to the given context. If the physics of the question says a particle comes to instantaneous rest, you must immediately interpret that mathematical trigger as velocity equals 0, use that to find your time t, and then use that t to find your constant for displacement. If you ignore the physical context of the math problem, you are literally throwing marks out the window.
Let's run a quick visual challenge right now. Spot how the rewrite on the right properly uses appropriate headings, clear annotation, and context-specific data interpretation. Take a good hard look at the screen. Over on the left, we have your classic, deeply flawed paragraph of math. The student has scrawled, integral of 3x squared equals x cubed. Wow. Okay, first of all, the dx is totally missing. Second, the plus c is nowhere to be found. Third, they jump straight to 8 equals 2 cubed, wildly trying to solve it in their head without explicitly stating the substitution. It is just absolutely covered in red examiner marks. Now, look at the right side. Look at the green checks. It's glorious. The student writes y equals the integral of 3x squared dx. Next line, y equals x cubed plus c. Next line, an actual helpful annotation. Substitute coordinates 2, 8 to find c. Then they show the clear working. 8 equals 2 cubed plus c. Therefore, c equals 0. And then the grand finale, the final explicit line. The equation of the curve is y equals x cubed. Do you see the massive difference there? The right side isn't just math. It is a mathematically sound, perfectly paced scene. It is specific, it is format-rich, and it is entirely context-driven. That is an A-star answer.
Section 5. We have arrived at the Mastery Blueprint. This is your final answering system.
To ensure your final cut on exam day is absolutely flawless, you must adopt the systematic processing. This is the complete system that guarantees top marks if you follow it religiously. Let's break down this 5-point blueprint. First up, command word decoding. You physically circle words like find, calculate, or show. And hey, remember, show means the final answer is actually already given to you in the prompt. So your working, your logical steps are literally the only things being marked. Second, framework application. Lean heavily on that math peel structure we talked about. Point, evidence, explanation, link. Third, the time management matrix. In a Cambridge 9709 paper, you roughly have 1.5 minutes per mark, so if an integration kinematics question is worth 6 marks, you have exactly 9 minutes to shoot that scene. Do not linger. Fourth, evaluate assumptions. This is a big one. Never ever assume the constant of integration is 0 just because the problem happens to involve the origin. You have to prove it by actually substituting 0 in. And fifth, justify with evidence. Your algebraic step-by-step lines are your undeniable evidence. If the question asks you to compare 2 areas under a curve, use comparative connectives in your final English statement to show exactly how your definite integrals mathematically support your final conclusion. Bring it all home.
Now here's the reality check. Students who implement these highly specific mathematical strategies see an average improvement of 2 full grade boundaries. 2! But, and this is a massive but, you cannot just listen to me explain this once, nod your head, and expect to be a master director on exam day. It doesn't work like that. You need to take this exact script, apply it to a stack of past papers, and practice this methodology until it becomes pure, unbreakable muscle memory. When you train yourself to automatically, instinctively write plus C and immediately scan the paragraph for the boundary conditions without even thinking about it, that is when you are literally hardwiring your brain for an A grade.
Time management and highly structured thinking are without a doubt your greatest assets in that exam hall. Every single complex syllabus point can be broken down into an actionable, bite-sized strategy just like this. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE, to excel in your Cambridge examinations. Subscribe right now to at Ace the Exams IGCS and click that bell. Don't let another exam pass you by while you're leaving 15% of your marks on the table. Listen. The constant of integration isn't just some arbitrary letter C that math teachers invented to annoy you. It is the exact, specific detail that solves the mystery of your equation. When you finally sit down for your 9709 paper, I want you to ask yourself, are you just blindly doing raw math and hoping for the best? Or are you executing a proven, calculated blueprint to secure every single available mark? The script is entirely in your hands right now, so drop a comment below with your target grade for mathematics and tell me the biggest challenge you're facing right now. Our team responds to every comment. Like and share this explainer with a study partner who needs to hear this. AC exams. Your Cambridge success starts here. See you in the next one.